awe and curiosity as the news anchor spoke about it. What is space? Why do stars twinkle? How did planets form? Why cannot light escape black holes? These questions shaped her early childhood. At 5 years of age, she was gifted a set of 25 encyclopedias, the I Wonder Why series. Hardly knowing how to read, born to typical Indian parents, she could do math before she could even read. She learned how to read not from storybooks, but from those encyclopedias. By fourth grade, she was much ahead of her class and always stayed a class topper. Later, in senior school, she bagged gold medals in math Olympiads, received Best Girl Student Award for excelling in studies, as well as co-curricular subject topper awards, science fair awards, earned junior diploma in arts, Kathak dance, tabla, and senior diploma in Indian classical music. In high school, she became the president of the school's astronomy club twice. She got selected for the final round of the International Space Olympiad and attended a space camp in Kerala 2016. She wanted to go to North America to study physics and astronomy, especially because she thought the resources at universities there are incomparable. Unfortunately, she was diagnosed with a debilitating condition called hidradenitis suppurativa at the third stage of scale. The diagnosis took time as it was still a rare name in India back in 2017, and she kept hopping from doctors to doctors in Jamshedpur and was even misdiagnosed. Went through a surgery which left her incapacitated for months. She wasn't able to use both her hands. Finally, she got a referral to Vellore and received the right treatment there. Her parents suggested that she join a college in India and go for masters abroad. She studied computer science for 2 years at Manipal, Karnataka, and then she transferred her course credits to the university at Buffalo, New York. Osho has been an NCC Cadet, youngest poster presenter at the Manipal Research Colloquium during her second semester, has been a part of the Mars Rover team, has organized the Indian Rover Challenge, and has been an undergrad research assistant during her second year at Manipal. She became a part of NASA's L-Space proposal writing and evaluation team. She was the CEO of a team of 11 across different time zones in the US. She has led a team of 18 amazing students across India to work on C.H.A.A.N, collective hive of advanced autonomous navigation and design, a lunar rover research project under SSERD. She again joined NASA L-Space to do a Mission Concept Academy. She was elected as the president of UB SEDS and is in the Council of Chapters of SEDS USA. She had the opportunity to visit NASA's Johnson Space Center for the SpaceVision conference and present her business pitch in front of business leaders in the space industry. Osho will now share her story as she pursues her passion in the field of space, and she will also talk about her transfer process from India to a North American university. Without further ado, I would like to hand over the stage to Osho.
Thank you, Andrea, for the amazing introduction. As Andrea said, that I was part of Manipal Institute for 2 years when I was in India. So when I joined Manipal, I was not in a really good health condition. I had multiple surgeries, and there was tumor diagnosis. It was for that hidradenitis suppurativa is like a very rare condition, and I was scared, like what will happen, what will I even be able to do now, and I won't be able to pursue my space dreams. So when I joined college, I joined different groups on Facebook that were related to hidradenitis suppurativa, and I found out that mostly the people who are suffering with disease are from the North American continent, the North America places. And so what I tried to do was I tried to survey the people who were in the group because there was no cure at that time for the disease. I wanted to find out what were the comorbidities, what were the common causes, and how people were managing that particular disease. So I got a whooping number of 500 to 550 people who took the survey. And then that was during my first semester that I posted the survey, and I kept that survey on. And during my first semester, I also joined the National Cadet Corps. I tried to get into that. I gave the tests, and it was extra difficult for me because I had to push extra hard because of my health constraints. But I was still in, and that allowed me to get over my condition really quick. And Manipal, the food and everything, it also helped me a lot. And then I joined the Mars Rover team. So that's like the most competitive team in Manipal. And even to get into it is considered like one big thing. And we participate in the annual University Rover Challenge, which is held at UTA. And our team designs the rover, and it's like a year-long process. So the first half of the year, you basically go through all the theories and everything. And I was part of the mechanical subsystem of the Mars Rover team. So I had to design the chassis and look into the suspensions. We actually had to watch the videos of different universities that had already in previous year presented their rovers, and we analyzed their videos. And we were actually at one point laughing at Stanford's design because that was not so good. And we usually stand fourth or fifth internationally in that competition. So that was like a big thing for me, and that's how I entered into my journey during my engineering years in space realm. And then by the second semester, I had enough data from the survey that I had put. And this time, like I'm from Jamshedpur, but during my winter break, I went to New Delhi. I stayed there throughout my winter break, and I met a data scientist, and he one-on-one taught me how to do data analysis and everything. That was 2018 winter break. And during my spring semester, it was a self-guided project, and I took more input. So the most important thing is networking over here. When you can just connect to people over LinkedIn and even on social medias like Facebook and Instagram, and they are really, really ready to help you out. So I connected with some people who were doing research on this particular field over Facebook. And I told them that I am a first year student. I have suffered with this disease, and I want to find out what are the comorbidities and what are the common causes, how do we get to a cure using data analysis and surveying people. So they helped me out with the research process, because in India, in most of the colleges, we are not taught how to do research at undergrad level. It's like people do it as part of their extracurricular, but it's not integrated in the course. And what I have felt as like a major difference between the courses and the curriculum in India and how things are taught in the US, because in India, every time we say like, oh, the education system, it's so bad, and we need to go to the US, we need to study there because the education system is great and people are doing amazing. Well, a lot of people who are doing amazing, and a lot of things that are happening over here, especially if you see the NASA aims research and all those things, all kinds of research. They are mostly Indian students or students from Asian communities, and it's and they are doing really well over here because not because of the system, but because of the resources that's being provided. Because the system that we have gone through is very rigorous, and it has prepared us really, really well. It has made our background really solid. So, but then we don't have the resources. So, what's important over here is to be a part of communities like Naxxatra and different communities that are now coming up and networking with people and collaborating within yourself and doing your own personal self-guided research work, because I feel that there's a lot of potential based on what work that we have done during our high school level and everything. So yeah, I connected with people who were doing medical practices and who were actually working in this field over Facebook. They were doctors based in the US, and they helped me out with the research process. And with their help and with my own models that I had made, I found out some interesting comorbidities and everything. And I presented it at the Manipal Research Colloquium. And then later on, when I came here, my first host was the person who was the admin of that group, and she told me to go to some conferences that happen within that realm and to make hidradenitis suppurativa more because it is very debilitating, and uh, there is still research going on, so have it out in the community. So that's one aspect of it. And then that's how I got involved in data analysis. And then by the time I was in third semester, I was a lot better health wise, and I tried to look into what are the options that we have to transfer our credits. Because you might have heard, and many people do know, that when you are in the US, you join like community colleges or you join certain different colleges and you can transfer credits. But it is very rare to transfer credits from India to US because of the disparity between the education system. So that's like something very unknown about. But then it is a really good opportunity. You end up saving a lot of money, and if you want to do education abroad and you're planning for entire 4 years abroad, you spend a lot of money. But if you transfer, you pay like if you transfer after your second year, you pay just for 2 years of undergrad abroad, and that's kind of efficient. You also get some scholarships, or you can get bank loans. And when you come here, you start working in like you usually get opportunities, especially if you are research oriented. You get a lot of research opportunities, and you get paid for the research that you are doing. So it's easy to pay back. And because I told that I'll be talking about the transfer process. So when you are in your first year in any university in India, the courses are usually common all across the world. You can transfer to Australia, all the universities, the top universities in Australia. There's ANU, UQ, Deakin, University of Technology, Sydney. I had applied to all these universities, and I even got into them. They are like the Ivy Leagues of Australia, but I personally wanted to go to the US. And then UK also, all the colleges accept your credits in the US as well. So after first year, transferring is pretty easy. Um, what you have to do is you have to give your IELTS. SAT is not necessary. And then you have to take SOPs from your college teachers. Your 12th grade scores don't really matter a lot. And just your first year credits, they do matter. And then you have to just go to the general sites, that's like the college app, etc., and just go there, fill in your application, apply, and once you get the offer, your visa process starts. So that's how you generally do it. And even after second year, there's a possibility, but then the course mapping is important, because when you're in your second year, there's the subjects get specific, so the universities get narrowed down. But that's also a possibility. For me, for me 90 credits got transferred, and I had to do just 1.5 year more. But I am taking a semester extra because I want to do internship and all later on. So you can plan your own course, you can take leave of absence for a semester and explore. All that is possible, and it's a great opportunity. So if anyone has any question related to transfer process, you can put it in the chat, and we can look into it after this. And now I talk about some of my projects. I'll share my screen. It's the first one. So this is the lunar water ice strategic science investigation. This is something I did with the L-Space. That is, it is a Lucy mission concept workforce development organized by NASA. And when I had already transferred after my third year, and when I was in my fourth year, I like last year fall, I did a few of the projects. I was like on Instagram. I recently created one Instagram account, and I followed all the astronomy groups and channels, whatever were existing. And I came across the L-Space program, and I just applied because their requirement said anyone enrolled in the US university. And there are very few openings for international students to get involved with NASA. And I just applied. Then I had an interview. I had some written rounds, and after that, I got into it. So this is a mission concept. Over here, our main goal was to have our lunar lander go on to the permanently shadowed region of the moon and extract some lunar regolith to find out the water ice content there. This is the mission concept of operations. This is our rover, and the rover lander detaches and ascends. Then there's the wheels that unfold, and the rover moves to the first drilling section, and then the drilling happens, and whatever the data is collected, it is sent back to Earth after analysis with high gain and low gain antenna. These are the mission requirements. The mission requirements and constraints. So when I was at NASA, and when I was doing all these studies, it's very important to have your requirements and constraints properly in place, so that you don't run into risks. Yeah. So that you don't run into risks of mission delays, risks of you try to minimize failure as much as you can. You cannot avoid failure at all, but you can definitely like minimize it to as low the possibility as you can. This is the descent maneuver and vehicle design summary. I was part of the science team, and being a computer science student, my role was data analysis and making sure that the rover moves in the correct path. So making sure that the navigation is perfect and it finds out the right spot to drill, it drills the right amount of substance. Those were my responsibilities. This is the rover design, the lander and propulsion design. This is the mission design frame, the drill, the drivetrain, subsystem weight breakdown. So everything, yeah, has to be specific because there are weight constraints, and you don't have, you should not go beyond the weight constraints. And then the aim over here is to have it sent to the Artemis mission, which is happening, and have the rover there at the permanently shadowed region at that crater. It's the Schrodinger crater that we chose to dig into. So these are our manufacturing plans, that how all the metal will be purchased and everything. Right now, we have thought about having all our purchases done from overseas suppliers, and have all the machinery related assembled within the US. But the thing is, with the recent pandemic, we are in a kind of critical situation, and most of the countries now are moving towards having everything entirely built within the country, all the manufacturing and everything, and limit the overseas purchases from suppliers. This is the risk analysis chart, the risk matrix. It's really important. The matrix, it's like the likelihood of risk happening and the severity. So you don't want to be in the catastrophic region. You don't want to be in this red or in this yellow region. You want to come to the green region as much as possible. So over here, these are like our numbers given to the different risks that we have analyzed. So propulsion launches to offer a slow landing for the rover, that's number one. And number one over here is catastrophic, because if things go wrong, I mean, it's like it's the end of the mission. So that's a catastrophic risk. And if the slow landing doesn't happen, and then suspension lands on the ground, providing shock absorption. Again, it's kind of over here. It is in the moderate column, but likelihood of it is a lot more, because it is the landing part, and the shock absorption can go wrong. That's like when all the testing should happen in the lab, and that's when we can revise the risk matrix and confirm that, okay, we have moved our like number 2 to green region. So this is what you do in the testing phase. You have your risk matrix after your preliminary design review, and then with each testing phase, you keep revising the risk matrix. And once you have shifted everything to the green side, then you are ready to actually launch the mission. And that's how most of the missions get, pushed back. Like now we are having the James Webb Telescope. We are hearing from a long time that, okay, it's ready to launch, it's ready to go ahead, but it's being pushed back because of these factors. Verification and validation plans. So like the science objectives and main design drivers. Landing site. This is important. Like I don't know if anyone here knows about JMARS tool or not, but it is available free on the internet, and it's a really great thing to explore. So you can download it, and you can explore different surfaces of different planets. Like you can choose Mars, and you can explore whatever the Martian surface has been mapped so far, and whatever the data is available so far, and you can go around and do your own data analysis on it. Then even for the moon, you can go to the surface of the moon and find out, okay, this is the crater over here, and fine, this crater doesn't look so good to have our landing site because it has a very steep slope, or it doesn't get uh, although it is in permanently shadowed region, it uh, it is prone to like more solar storms or something like that. So you can do all kinds of analysis and decide which crater you want to go to, and you can have your water ice sample from there, and then do further analysis. So that we decided to go to Schrodinger crater. The diameter was 312 kilometer, and we thought that because it is topologically flat, it will be a good place for our rover to traverse and collect samples from different areas. These are so expected data and analysis. My part was over here to use Kalman filter and make sure that when the rover is moving forward, it is analyzing its path, and as and when it is collecting, drilling into the lunar soil, and when it is collecting the ice sample, and when the rover's computing module gets a signal that, okay, we have some ice sample, then the Kalman filter updates that, okay, this is a preferable location. And then it moves forward. Suppose in its first iteration, it doesn't find any ice sample. Then the Kalman filter updates that, okay, this is not where we are going to come back. This is the, like, it marks it with a certain coordinates that, okay, I have been to this place and this is not what I'm looking for. If it goes somewhere else and the soil texture is similar, it tries not to waste its power on drilling into the same place, and tries to move ahead and go to a place where the soil texture is a bit different, so that it can start drilling. Then next steps, critical design review, and as we said, testing and prototyping. That's the most important part. And then this was like one of the projects that I did with L-Space. I'll show you another project that I did, which was the quad chart. This is where I learned how to make quad charts and do proposals. That's when I got to interact with people who were working in the NASA, who actually select which mission goes forward, which proposal is selected, and we had to actually analyze different kinds of proposals. In fact, when we were presenting the quad charts, one of the quad charts that I presented was on our team had to present 4, and 1 got selected for further proposal design. And the proposal, unfortunately, I can't show, but this is the quad chart that got selected for further proposal. And this is the NASA data management and collaborative framework. So the thing over here is that your metrics and key performance parameters, these should be like very accurate, and as accurate as it is, more is the chance that your quad chart gets selected for further proposal development. Over here in this area, you generally have a picture or a map of what you are planning to do. Here you have your goals, your main goals, then you have your objectives, and then you have the team overview, like who is skilled in what, and tentative SMEs. SMEs are people, experts from NASA's who can help you with this development. So I think it is not just specific to NASA, it is specific to any space industry. So I think even ISRO should have the same way of carrying out its proposals and everything. I am not very sure about different agencies, but I assume that it should be something similar. So then we got trained about how to go ahead with making your patent, because patenting is again a big system. It's expensive and it has got a lot of clauses, and you have to go through a lot of procedures. So over here we plan to have data management and collaboration framework, because what happens with NASA, because NASA organizes a lot of competitions uh, for universities that are in the US, and now it's also doing things at international scale. For example, the NASA App Challenge. I don't know if you all have heard of it or not, but it is also a great project uh, to do if you have some good idea, and if you win, I think they give you some funding to develop it further. So because we have a lot of data that has the potential to develop into future missions, we don't have a proper data management plan. There is like a decadal survey that happens of like once every decade. So it is time taking. So what we wanted to do was have a new data management plan set up over here. So that's one of the projects. Then when I worked with C.H.A.A.N.D when I was in India, there were Team C.H.A.A.N. So this is our Team C.H.A.A.N website, and we are a collective hive of advanced autonomous navigation and design. And we actually worked on a swarm rover system to serve our mineral excavation plan, and to establish a mesh of lunar communication network. So the most important thing over here and the most difficult thing over here is how are you going to communicate when you are on a different planet, because when you're on moon, the communication lag is not uh, high, and even when you are on the surface of the moon and you have different swarm rovers that have different rovers that have dispersed from the queen rover, um, how are you going to communicate with that swarm and the queen? How is the communication happening? And later on, when you plan for future establishment of, say, even a temporary base, or later on even a city or something, um, how are you going to communicate? So a mesh of communication network is really important, and that was something we decided to do. So these are my team members, and this is our team presentation that you can also download from our team website. Uh, so there were different subsystems within the team. This is our mission, vision, and objective. Our immediate objectives were to ensure soft landing. The aeronautical team, they worked on this and create a robust chassis which ensures safe traversal and of the lunar terrain, and build computing modules to help navigation, find perfect site for excavation. And the most important part over here was to establish a lunar communication network with the help of swarm robotics as the rovers disperse away from the queen. And what we had planned was that we will be dropping repeaters as the rovers they will move away from the main queen rover, and the mini rovers will keep communicating with the repeaters, and the repeaters will amplify the communication signals. For powering of the rover, there was a different wireless power team. They tried to like research on wireless powering technology, although the data that the output that we got, the conclusion that we got was wireless powering is not right now is not powerful enough to carry out the rover functionalities on the surface of the moon. So MMRTG might be the option so far right now, but there are other options that definitely can develop a lot better, like the solar options. But then when you are going to the permanently shadowed region, it has to be something like MMRTG. This is the soft landing and fuel optimization. This is what the soft landing subsystem worked on, that it was their problem statement. The conclusion that the soft landing system derived was that they actually worked on something called Hamiltonian profile. If some of you are from aeronautical or maybe mechanical background, I think you might have some idea about it. So they found that it is almost constant over time, which illustrated that whatever they were trying to achieve, their results were optimal. This is the kind of chassis that the mechanical subsystem made, and they went ahead with the Mantis design. There was like a lot of discussion that happened and a lot of revising and everything. This is the design of the mother rover. And these are the swarm rovers that disperse from the mother rover. This is the animation. I don't know if you're able to see the animation. Can someone tell me? Are you able to see the animation? The video?
Yes.
So here, this is the camera where we'll get inputs as the rover navigates further. This is our theme mark. And this is from where the swarm rovers come out. Yeah, and then we had the excavation team. They had, so over here, this was actually my idea to have a bucket, a sample bucket attached with the outer cylinder, because personally, I also had some knowledge with the chassis and rover design, because I had worked in the mechanical subsystem of the Mars Rover team when I was in Manipal. So I had done a bit of designing of rover chassis and and some kind of excavation mechanism as well. So we plan to have some sort of bucket attached as the drill bit goes in. It collects while it is drilling, so that we don't have two different mechanisms. And when it comes up, we have like over here we have three different sorting layers, so that the soil, according to its course and structure, gets sorted within the drilling mechanism. this is how we have planned to drill into the surface. So now coming over to the compute module and the swarm communication, actually more important, because this was the heart of our mission. Like even when you see in the nature, there are different kinds of swarm assemblies that happen. For example, bees, when they do swarm self-assembly, and birds when they form patterns. So these are done to make sure that it can perform difficult tasks when it organizes in huge assemblies. And that is what goes behind the swarm communication idea, because we wanted to establish a mesh of lunar network, and we thought that swarm rovers will work the best over here. Our computing module. We have actually a research paper over here done, and if anyone is interested, they can email to the email ID provided on the website, and then we discuss and we send it to you. So this is the compute module, and this is the module that was created by two of our really talented team members, Srinivas and Siddharth. They created the size of the activation layer is 336, and over here they went with this neural engine just so that there is enough monitoring of the system, and there is continuous chain of rigorous tests that happen every time the rover is moving forward. And this is the feedback and systems health monitoring unit. So this is the initial stable build. Then data is transferred to the new build and updated firmware in forms of output signals. And from here, it like this is the final the updated firmware always. And then over here also you have the previous build with errors. This also sends update signals, whatever is the signal in zeros or ones to the new build. It sends signals to the feedback loop, and that again sends signal to the initial stable build, whether you have to do the build once again or whether the new build that you have is correct. So for example, in my previous document that I shared, I told you that when we are using Kalman filter, we need to know that, okay, when the rover has, say, collected ice samples from a certain region, we are sure that, okay, this is the soil texture, this is the ground where we can possibly find more ice samples. If it has done that, then we don't need to go back to our initial stage and build it again. But if it doesn't find it, then we need to update something. So that's something on feedback loop. And over here, we wanted to have that for navigation purposes. This is our more details on the compute module. And this is the work that the wireless power transmission people did. And it's actually, whenever you are writing a research paper or whenever you are doing things like this, it is very important that you explore every possibility. You don't cancel out things at the very initial stage. And even if the conclusion is that, okay, this doesn't work, it's a valid conclusion, it's a valid research paper, because you need to know what doesn't work to get to what works. So we basically found out that the wireless power transmission doesn't work, so we should use either solar or MMRTG, and everything else was to the point. And our the future prospects over here is to set up a 3D printing hub for building and extracting water ice from the lunar surface, and using said water ice, growing plants and extracting hydrogen, rocket fuel. So basically have a chance city established on the surface of the moon. So this was one of our C.H.A.A.N.D projects. And yeah, so other than that, I think I can take questions now, and if something else pops up on my mind on research framework or anything else, I'll give the inputs. So to you, Sitara. Am I audible?
Yeah. Andrea, are you here?
Yes, I'm here.
Okay.
Yeah, so I think I can take questions now. And if something else pops up on my mind while answering, I'll definitely put it over here.
I think today we can allow people to unmute and just ask questions. And also, that was a really interesting and like super broad overview of everything you've done. So really enjoyed the talk. Thank you.
You're welcome. Glad you enjoyed.
Yeah. So if there are people here on the Zoom call who would like to just unmute and talk, you're welcome to do so today. And I'll also keep an eye out on YouTube for the next 2 minutes.
What kind of opportunities would be available for students who have completed their degree but have not been involved in research during college? So, Saifa, what do you mean by opportunities like in India, and what degree are you pursuing? So I can give a broad overview. So if you have not been, or you're not able to unmute, can you let Saifa unmute?
Yeah, hello. Hi. I would like to thank you first of all. It was really interesting talk. Like did touch upon many areas that I am interested in. So that was really great. So yeah, coming to my question, I was like as in I do want to be a part of these fields. Like I have some experience in controls and ROS and everything, but I did not really involve like we did not have any research project opportunity in my college. So like even for applications abroad or even to get into the field, like I would really want to know how to get involved in research projects or like get projects anywhere, even in India or abroad. Like what would be the path to go about it?
Okay, yeah, really good question. And so what year are you in? Are you doing your bachelor's? I think you are muted again. But if you are doing your bachelor's and if you still have time, like even a semester or a year left, and what you can do is you can approach your professors, depends upon the colleges. Okay, you just got done with your EC. Oh, okay. Cool. No worries. It's absolutely fine. And I think you're looking for masters abroad from your question. I can understand that. So what you can do is while you are still applying, you can go on to self-guided projects, because even when you are in undergrad courses in India, especially if you are in the universities that are more towards the eastern part, like there are not many research opportunities when you go down south, because there are space agencies, and there's ISRO. There is more involvement of people into research, but hardly any good research output, especially from cities in Jharkhand, like where I come from. So what you can do is you can just cold email people in the field that you're interested in. So you said you have some experience with ROS, etc. So just find that who are the people, just Google search who are the people who are doing research related to the topic that you're interested in. And you might find some professors who are, say, in IIT or triple IT, or like I know about Manipal, they also have like really good research options and research facilities. So even if you find someone there, you can just cold email them, connect with them over LinkedIn, or you can join Facebook communities of colleges, like you can find research communities that are there on Facebook, that are there on Instagram. And say you are interested in a particular university that you want to transfer to. For example, University at Buffalo is a very good research university. We have a lot of research output. And I'll tell you something about myself, that how I got involved in research after coming to Buffalo was I cold emailed a professor who was working in the geology department, because personally I'm very interested in the texture of ice and snow. And in Buffalo, it snows a lot. So that was another reason why I transferred to Buffalo. Plus, it is in New York, so you get like decent pay, and the living cost is less. So it was a good opportunity for me. And when I came here, I cold emailed the professor who was working in the geology department, and who was actually working on snow and lake effect in Buffalo and trying to analyze the ice samples. Because personally, my aim is to do that on the level of on ground level on Earth. And then right now, I am involved in that project and I'm getting paid for it. Like that, the salary is the salary you get for any internship. So I am able to manage my own living and everything. And then when I'm doing the research, I like there's a lot of scope for it. You talk to your PI, and they are like, okay, for me, we are planning to have that model extended to analyze the global crisis of melting of ice, and then take the same model to different planets like Mars and Moon, and study the ice samples there. So you have to first brainstorm and write down what your ideas are, because what is most important when you are transferring to any university abroad, or any North American university, be it Canada, be it US, the professors see what is your drive to do research, because they get a lot of research output, especially from students who come from international backgrounds, because we had a different kind of theoretical preparation for a lot of stuff. So when we put it into practice, it's like the professors know that there is a lot of potential, so they won't deny you. Just find a university that you are interested in, find the department, and when you go into the department section, you'll have the names of all the professors listed down, and then you can compare it with their research index on Google Scholar. You can go to Google Scholar, type the name of the professor, and you'll find the research index. And if it is high, then that means that he is a good professor, and he might give you a research opportunity. And then email him, tell him why you want to do a particular project. Why you want to do a particular project, and he will he'll most probably take you into the research team. And also, it's not always that you get paid, but again, it's not about getting paid. When I was in India, I was getting paid, but it's about the drive to do research. So sometimes you get stipend, sometimes you don't. It really varies from professors to professors. So yeah, that's one of the ways how you can do. And that's also, I think, one of the most important way to get into a college where you want to do masters. You first connect with the professor, you connect with the research work that they have done, you read some of their research papers, and then they themselves will write a recommendation to the university to take you in for the master's program. So that is one of the ways. And even before you are going, maybe you can start some of your self-guided research project. Just find people, like-minded people who are into it. And even if you don't find like-minded people, you can connect with experts and just tell them to mentor you, to give you some inputs. And when you're doing research, sorry. When you're doing research, the most important thing is that you follow certain citations. You make sure that you do not plagiarize at all. That's like, and the way to avoid it is make sure your citations are apt and to the point. So one of the resources to follow is Purdue OWL. And they talk in detail about how to do citations, how to write your research inputs and everything. So you can check out that website and you can self-learn, and you can like begin your research and everything. Did that answer your question?
Thank you for answering Saifa's question, Osho. We have another question for you. The question says, I have heard about Starlink project, but I don't understand how it decreases communication delay in space communication. All EM waves travel in the same speed. Then how is it different from the current technology of radio wave transmission as of now?
Okay. Yeah, so with the Starlink, the main idea with the Starlink project is they have a series of satellites. So it is not just one satellite. Just the way I talked about the swarm communication that we are trying to establish on the surface of the moon. We have the main Queen Rover, and then from the Queen Rover, Swarm Rover disperses out and drops repeaters to establish a connection between. So if here is my main Queen Rover, and here's my other Swarm Rover, and there's a repeater in between, the repeater amplifies the signal between the Queen Rover and the Swarm Rover. And so on. There are different Swarm Rovers and different repeaters in between, and they keep amplifying the signals. Excuse me. So with the Starlink, they have a series of satellites, and now there is, in general, what we have is like just one satellite that is helping us do the communication. So it's one-on-one. With Starlink, there is like a series. So you can imagine a series of repeaters, and each of them amplify the signal. So that's how it gets, it gets stronger in data transfer and everything. The physics behind it remains the same. It's the same electromagnetic waves, it's the same radio signals. It's just the technology that they are using. They are trying to amplify it after short, limited intervals. Did that answer the question?
I think most probably, Osho, because this is like the question was asked on the YouTube live. So
Okay. I hope so.
I think there's a follow-up to the question. How is it different from, or was that already, I'm not sure if it was already addressed. Taki says, how is it different from current technology of radio wave transmission?
I am not very sure how it is different from the current technology, because personally I have not worked in the Starlink project. But what I can tell from my present knowledge is the technology is not different. The technology stays the same. It's just the way it is being amplified after every short interval. The radio signals that is being sent. So Starlink is like a series of satellites. So from one satellite to the other, and how it amplifies. So from Earth, when you are sending signals, it doesn't have to wait that, okay, only one satellite needs to catch it. Any one of the satellite catches it, and it amplifies the signal with respect to its nearby satellites and transmits it back to you. That is what I think happens. Personally, I'm no expert with the Starlink technology, but I don't think any different physics was used. It was the same radio technology, radio wave communication.
Cool. I personally have a question for you.
Yeah, sure.
So after going there, right, what is some kind of fundamental difference you notice in terms of perhaps the pedagogy style, or how you're exposed to the concepts, or even the approach to a particular research project? And in terms of resources, you spoke a lot about how, in the beginning, you spoke about how resources makes like a lot of difference, or the bridge, right, to accessing such opportunities. So what is the primary difference?
Yeah, right. So so there's a lot of differences that I noticed after transferring here at undergrad level, because like after doing 2 years in India, when I transferred here, so one thing that was there when I was in Manipal, and I know it's different in different universities across India, but Manipal is heavily focused on student projects. So they invest a lot on, there are tons of student projects in Manipal, and they invest a lot on these projects. So students, they come together, they, like I remember when I was in Mars Rover Manipal, we used to have task phase that was like very rigorous. As soon as class ends, 5 p.m. onwards till like 12 a.m. you are committed to that. Every day you have to send in your guided whatever you studied and everything, participate in the next discussion. And as you get closer to the prototype phase, you are there till 2 and everything. And people get, because India, huge population, there's huge competition. So people get checked out, people get kicked off if you are not putting in the right amount of work and everything. But on the other hand, the regular coursework is not very tight. That's why it's the student efforts that matters more in India, because our education system, the system is not bad. The way it is executed, the way it is carried out, that is bad. That is pathetic, actually, especially in most of the private universities, because I'm not saying about Manipal. Manipal was okay, fine, but there are so many engineering colleges in India, and they are just there for namesake. So firstly, how teachers deliver course information to students, that's that's like way different. And over here what happens is you have lectures and everything. Attendance is obviously not compulsory, but there are like every week, especially in computer science, we get assignments that's like heavy-ended. Your coding projects and everything is like 12 to 15 pages long questions that you get, that is due Friday of every week. And then you have lab questions that are themselves 10 pages, that's due Monday of every week, and each of them carry different grades. And then you have academic integrity policies. So in India, what happens is like when you and there are deadlines every day, like 3-4 deadlines every day. You get a lot of projects, and you have to work throughout the course. If you slack even a day or two, you are out of the loop. It's difficult to catch up. And so what happens in India is like you get an assignment. Some people, they just go on Wikipedia and take it out, and even teachers don't care. Teachers don't check, and they're like, okay, fine, this is the project done. But over here, it goes through every assignment goes through a plagiarism engine. And if the plagiarism percentage is higher than a certain number, or even if there is like a % of plagiarism in some courses, especially in your coding courses, it's like you get an academic integrity thing, and you cannot get employed in the US anymore. And things are like that. So courses are rigorous, but the course content, I feel it varies for computer science, the way a certain professor structures their courses. But over here, what I see in India, people do a lot of outside the curriculum courses. They join, say, there are different like coding ninjas and all that. They join all those to, make themselves more employable. But over here, if you just go through the general course, that's enough. You don't have to do anything external. So everything is within that, within the course structure. And also in terms of research, in India, I think research options are there, but it is not compulsory in most of the universities, and in some universities only in your final year. But over here, there is research and there is thesis writing and everything in literally every subject that you do, starting from 100 level course. That's like your freshman year. So it varies. It's not heavy-ended research, but as you move forward, the content that you have to put in increases, and you have to go through all the research training and everything. So it's within the course. But in India, you have to, if you're interested in doing it, you have to self-learn and everything. So that is another difference that I noticed. And then in terms of studying over here, you have to do a lot of individual work. There are very less group projects that are given out. And what I saw in India, there are a lot of group projects, but I feel that group projects are good. So that is something I give upper hand to the Indian system. And then when it comes to maths, I'm like, why do people even come here to do maths? You should go to India and do your major in maths, because we really have a great course structure and everything when it comes to mathematics. So that's one thing. And these are some of the differences that I noticed. And over here, you have to choose your own professors, you have to choose your own classes, and again there is a competition to choose classes, because if you are not on time to choose what courses are you taking next semester, the courses get booked, the classes get booked, the professors get booked, and you're not able to take your required courses, and you might not end up graduating on time. So you have to be on your toes and be alert all the time, like what's happening around. And then when you come here, uh, do you think the Indian education system provides a good base for observational research as a career, or would you suggest studying elsewhere? Anitra asked, okay, so I'll just finish Sitara's question. These are like the main differences that I noticed over here. And especially when you come here and start doing your research, more than often you get paid for it. So then you have to manage your taxes and everything. So for me personally, coming here, this was my first year. So I had to, usually in the first year, it's difficult to get an internship or something within your major. People generally work like cafeteria or something, but for me it was kind of difficult. But when I got it, even adjusting to it and adjusting to the system was like overwhelming within a year. And I also joined UB SEDS over here, so that is Student for Exploration and Development of Space. That's like a huge thing over here in the US, and there are chapters in every university. So basically SEDS, they launch rockets, they take part in the Spaceport America competition. We have astronomy, and within space we have different subcategories of work that we get to do. So I was elected as the president, and then I'm also in the Council of Chapters for SEDS. So for me, it was getting to know the system, how everything works, because when you're the president, you have also to take care of the economy that's happening inside, how the money is transferring, coming, and getting sponsors and all that. So it was a lot of work, but it was a lot of growth at the same time. So these were kind of subtle differences that I noticed, but then that is what I came here for. So yeah. I hope that answered your question, Sitara.
Sure, yeah. I think Anitra's question is kind of similar, but talks about observational research as a career. So do you want to quickly address that?
Yeah. So I'll quickly. Yes, I think the Indian education system provides a good base for observational research as a career. And I think in India, there are new organizations coming up, and there is, I think, IUCA. I saw that there were a few panelists that Naxxatra had from people who were in IUCA. So they do, I think, research on LIGO and gravitational wave, the gravitational wave detection, and the study that you do in India is like very, very solid. So I don't think you need to pursue a career elsewhere. Maybe when you get into the field, you can go to different places as an intern or as a part-time, or just for a few months as an exchange person to see how different things work. But India has a solid groundwork over there.
Yeah, I think I can, I agree to that. There are a lot of, I think, observational institutes doing pretty good work. I think it's about how, I guess, efficient and proactive you can be in kind of getting access to such opportunities, as well as the data, right? Because when it comes to observation, there is like instrumentation and then the data. So
right, absolutely.
Yeah.
Okay. So I recommend joining some of the new groups that are emerging in India, and I think they are doing a really great job. For example, you are in Naxxatra, and there is VOA that they also talk about a lot of opportunities within India. And even if you are in different sectors, there is a lot of space opportunity, and in fact, India has a lot of potential. For me, like, I want to come back to India after finishing my studies and research here, and like do my work related to space in my home country. And yeah, there is like space economy, space biology, space political science, because space laws, because as the commercialization of space is happening, we need different space laws. And there are a lot of stuff. I can keep talking, but I think it's getting late. Is it?
Yeah, but I think you've covered like a really good amount of the points that have to be, I think that will offer really valuable insight to especially undergrad students. So
Exactly.
are you, Andrea, do you want to add something and then we can close in about 5 minutes?
Yes, sure, Siddhartha. Does anyone have any more questions? We would like to give the vote of thanks.
Yeah, I think you can go on. There are no further questions. And we can always, I think, just like similar to previous talks, if there are other questions, or even, I guess, questions from our group, core side, we can always keep in touch with Osho in terms of through mail or whatever it is to get answers later.
Yeah.
Actually, the vote of thanks, Anitra was supposed to give it, but she's unable to unmute because she's not the co-host. So can someone just make her...
Am I audible?
Yeah, thank you.
Thank you, Andrea. As we come to the end of yet another episode of Cosmic Tales, I, on behalf of the Physics Association of Mount Carmel College, would like to extend my sincere gratitude to Ms. Osho Priya for taking time off her schedule to be amidst us, to share her story, fascinations, and work with fellow space enthusiasts. You are truly inspiring, and we wish you all the very best for all your future endeavors. I would also like to extend my thanks to Naxxatra Sciences for giving us the opportunity to host you all this weekend. We hope you all have something to take back from this session. Thank you all once again. Have a great weekend.
Thank you so much.
Thank you, Osho. Thank you so much.
This was really fun, and I think there's so much we learned from you and also so much left to learn. So definitely do keep in touch. And I think we have to keep helping students like you and me. So thank you for showing up on the platform. Yeah.
Okay. I'm really grateful that you all invited me for this.
Yes, thank you so much, Osho. If we have any other questions, we'll email them to you.
Yeah, sure. I'll love to answer them.
Cool. Thank you, Andrea and Anitra. It was really nice. See you.
Thank you, Sitara.
Thank you, Sitara. Thank you, Andrea, Anitra, and I see Prerna over here. I don't know. And everyone else for being here.